In this video, we'll look at an example of finding the area of a region bounded by two curves. For this one, you're to find the area of the region bounded by the curves y equal to x, which is a straight line, and y equal to x cubed. So in this case, the curve y equal to x is in blue, and the curve y equal to x cubed is the one in red, and I shaded in the region bounded by the two curves. Now in general, let's say if you had one function f of x is greater than or equal to g of x on the interval from, let's say, from a to b, then the area of the region bounded by those two curves within that interval is equal to the integral from a to b of f of x minus g of x. So it would be dx. So it would be the integral of the function on top minus the function on bottom. But now if you notice for this graph, let's say it looks like from negative 1 to 0, the graph of x cubed is above the graph of x. But from 0 to looks like 1, that the graph of y equal to x is above the graph of y equal to x cubed. So what do we do in this case? Because if we did just try to find the integral from negative 1 to 1 of one function minus the other function, and it actually wouldn't matter which one, we'd actually end up getting 0 as the answer. Because if you did take the integral of the bottom function minus the top function, you would actually get the negative of the area. And it looks like the symmetry of these two graphs, that the areas are the same. It's just on one, again, the x cubed is on top of the x, but the other one, the x is on top of the x cubed. So what we got to do is to find first, where do these two graphs intersect each other? So let's do that first. So let's first find where do they intersect each other. And we would do that by setting the two functions equal to each other. So set x equals to x cubed. And let me subtract x from both sides. You get x cubed minus x. And then factor out an x. We'd have x squared, x times x squared minus 1, which is the same thing as x times x plus 1 times x minus 1. So using the zero product property, that we have the 3 points of intersection would be at x equals to negative 1, x equals to 0, x equals to 1. Now, to find the area, let's say, of the first region on the left-hand side, we would have to find the integral from, looks like from negative 1 to 0 of the top function, which in this case is the x cubed, minus the bottom function, so the x, dx. And then for the area of the second region, you take from 0 to 1 in this case. It would be the top function, which is the x, minus the bottom function, which is the x cubed, dx. And you would add those two together. So let's see, so integrating this, see, for the antiderivative of x cubed minus x, that would be what, 1/4 x to the 4th minus 1/2 x squared. Evaluating that piece from negative 1 to 0. And then for the second one, the antiderivative of that would be the 1/2 x squared minus 1/4 x to the 4th, evaluating that from 0 to 1. So for the first piece, let's see, plugging in our upper limit, we'd have 0 minus 0 when we plug in x equal to 0 into it, so that'd be 0. Minus plugging in negative 1, that would be what, 1/4 minus 1/2. And then for the second piece, let's see, plugging in 1 into the antiderivative, we'd have what, 1/2 minus 1/4, minus, then plugging in our lower limit, you'd get again 0. So let's see, that would be 0 minus, now 1/4 minus 1/2, that would be negative 1/2, or sorry, negative 1/4. And then plus 1/2 minus 1/4, that would be 1/4 minus 0. So that would be negative negative, so that would be positive 1/4 plus 1/4, so that would be 2/4, which would be 1/2. So that would be the area of the region bounded by the two curves. So what we need to do is we need to find the point of intersection of the two curves and then determine for the different pieces which function is above, which one function is below. Now, in case you didn't have the graph, what you could always do is, let's say if we didn't know between -1 and 0, which one was on top, which one was on bottom, you could plug in a number between -1 and 0 into each one of them and just see which one gives you the largest value. And same thing from 0 to 1, you could just plug in a value, let's say 1/2, into the two functions and just see which one has a larger value when you plug in that 1/2. That way you'll see which one's on top, which one's on bottom. Now another thing is that if you couldn't do that, well, you could always do that, but let's say if you didn't want to take the time to do that, you could break it up into those two integrals, and then you could just take the absolute value of each one, because if you did it incorrectly by having the one that was actually on bottom first minus the one that was on top, you would just get the negative of that area. So you could just take the absolute value of that. So that would be another way to do it.